communication between the modules might be a bit better. Also, Eddie had initially had problems with his with his Java outputs with the graphics. There seemed to be a lot of jitter when you're moving between buttons and between windows. And we fixed it for now, but maybe Flash would have been a more stable interface to use for our web-based interfaces. And finally, when you change moves using our recorder, you have to input coordinates, you have to fill in fields and click buttons to change moves. We think that maybe it would have been a little more user-friendly if we had some sort of drag-and-drop mechanism where you could drag pieces on or drag pieces off to change moves instead. And we'd just like to thank these people for all the support, and now we can take any questions that you might have.
Yes.
Well, I have a twofold question for you guys. The first question is going to be deals with how do you plan to attack the possibility of the server going down, let's say the router going down, let's say the camera, the physical and logical aspects of the camera going down, both the software and hardware. That's the first question. And the second question is, have you thought about moving the server to a wide area network where as many people from all over the world can access the server and use the game?
Well, to address your second question, it is an internet server. You can access it from any point in the internet. It's not just for the local.
So it's not local. I mean, I know
the administrator
local.
needs to be on the local area network to access the camera. And
Okay.
the router acts as a gateway, which is a security mechanism, actually, because if people on the internet can access the camera, they can actually mess with the games that are going on. So there is a local area network that the administrator should connect to and can connect to wirelessly. But the server itself and the user interface is accessible on the internet.
For the first question, I mean, that's one of those things that you can't really, it's sort of like external factors. So I mean, some of the things that we have in terms of the router and all that, we got the more stable systems, but we don't really have, what happened with the games that we recorded, say the server breaks down or anything like that, we have this constant saving and auto-save type of mechanism that's working. So each time pieces are detected, it will be saved into a file, the SGF file. So in terms of having a backup of the files that's going on, we have that. But in terms of, say the camera blows up, there's nothing you can do with that.
So basically, in the case that something happens on the server, you have points, like checkpoints that are saved that would bring back the game,
Absolutely.
bring it back up.
You mentioned that actually, what happened is if a game finishes recording and there's some change in lighting or whatever that is, once you have the SGF file, we have a mechanism to reload the SGF file, which is an added feature that we did. It gives the admin the user-friendliness where you can upload the game and can start modifying from there on again.
Okay.
And also,
if there is a failure and it happens to change the SGF file, we have that mechanism that you can edit moves and make sure that it's up to date with whatever actually happened, and then continue from that point. So,
can I just touch on that?
Let's move on to the next question.
I have two questions. First of all, I was very impressed with the image processing, so
Thank you.
very good. One thing I didn't quite follow, I don't know if you mentioned, how did you detect intersections of lines?
the intersections? Oh, we didn't need any of that. When you form the projected transformation, we know where every intersection is going to be, because what you do is you have control points in the image that you find, and then you map them to control points in the projection that where you want those points to be.
But
So-
once you know even projected, so this is basically orthonormal grid,
Yeah.
you still need to know where are points where you can place the pieces, right?
Well, they're going to be at regular
Also, you
coordinates.
assume
They'll
you
always
space
be-
regular and you just divide the distance and you assume
Yeah.
this is, so you don't need to detect it.
No.
Okay. Second question is, I know that you started with Axis 206 and you dropped it. I mean, what was the reason? Why did you go to Panasonic and so on?
There was a problem with radial distortion with the camera. It had a very good image quality, but I think because the lens was so large, there was a lot of barrel distortion, and that's a big problem with projected transformations. You have to have straight lines and being mapped to straight lines.
So it wasn't so much communication or SDK
No,
or
nothing
anything,
like
it was the lens.
The newer camera has like a pinhole lens almost, and that means that it had very low distortion, but the image quality isn't so great, so we had to overcome that problem, the noise problem, which is less of a problem than distortion. So we went with that camera.
But quality was because of compression or because of
We think because it's such a small hole, not a lot of light getting in.
some noise, basically?
Yeah.
Thank you.
Well, your project looks very successful, and I was wondering if you could say anything about what you did different from last year's team. They did the same Go game, but I don't think they got that far. What you did.
Well, number one, it's because last year they tried to build an embedded system with an onboard camera, so they spent so much time on the hardware that they did not have the time to build, the software. And besides, what happened is building this embedded system, they have to program using assembly language, and trying to do all this image processing, trying to program in assembly language is quite a task. And what we did here is we actually built MATLAB, and it has a lot of image processing tools that we can use. So that helps a lot in terms of doing that. And we have a lot more time to focus on developing the software part of it.
Yeah, we think that basically the image processing algorithms are very simple. They look like they just looked at specific points. They made sure that the camera was directly above at the exact same position every time. And apparently in different lightings it really didn't work. I mean, we don't know the specific details of how their algorithms work, but because they were limited to programming everything in assembly, we assume it was very hard for them to develop the image processing.
Final question?
I have very naive question. If somebody would ask you to move from Go game recorder to chess game recorder, is it order of magnitude more complicated or is it just impossible?
Well, first of all, the Go pieces are all round. So, detecting chess pieces would be difficult because
But
you would
have
have to have some sort of different angle to get, for example, the shape of the different pieces. It would be much more difficult, I think, because Go is the convenience of Go is that you have opposite colors, black and white, and they're all round, and so that made it a lot easier than say something like chess.
For next year's.
We got the Kenny detector so they can actually detect the board, and we'll have the next year's team work on detecting the pieces.